design thinking based content. Bayesian inference is a statistical method that updates the probability of a hypothesis as more evidence becomes available. It bridges data and decision making by allowing continuous learning from new information through the lens of design thinking. We can explore how Bayesian inference mirrors the human-centered problem-solving process, empathizing with data users, defining the problem clearly, ideating probabilistic solutions, prototyping models, and testing with real-world evidence. Further, will explain Sabrish. Sabrish, can you define empathize?
Yes, ma'am. Empathize. To empathize, we first understand the uses of Bayesian inference. Data scientists, medical professionals, engineers, and researchers, all of whom need a method to make sense of uncertainty. For instance, in healthcare, doctors must make diagnostic decisions with limited data. Understanding their challenges, uncertainty, risk, and evolving information helps frame Bayesian inference as a tool that empowers better judgment.
Okay, nice presentation. Karthik, can you define in Bayesian inference?
Yeah, sure. The problem is clear, traditional statistical approaches assume fixed probabilities and lack adaptability. When new data arrives, we need a method that updates beliefs dynamically. The definition of the challenge becomes how might we create a framework that continuously defines prediction so evidence accumulates. Ideate will be explained by Rajit.
The ideation stage explores ways to integrate prior knowledge with new evidence. Brainstorming leads us to the concept of Bayes theorem, combining prior probabilities with likelihoods to produce updated posterior probabilities. This becomes the creative solution that transforms statistic reasoning into adaptive learning. Next, prototype will be explained by Arun.
The prototype stage involves building simple Bayesian model. For example, creating a basic model that predicts whether an email is spam or not. Based on words it contains and prior observation. This prototype serves as learning tools, allowing us to test Bayesian interference principle in small, controllable environment. Next, test will be explained by Karthik.
Test involve validation the model with real world data. As new evidence comes in, the Bayesian model updates itself. We initiate its accuracy, reliability, and adaptability. Feedbacks help refine process and likelihoods, reinforcing the iterative nature of design thinking.
Okay, we conclude that Bayesian inference, that design thinking mindset, empathy for uncertainty, clear problem definition, creative ideation, experimental prototyping, and evidence-based testing. It transforms probability from a statistic calculation into a dynamic learning process that evolves with experience. When we look at Bayesian inference through the lens of design thinking, we realize it's not just a mathematical concept. It's a mindset for learning, adapting, and evolving with data. Just like how designers empathize with human emotions, Bayesian inference empathize with uncertainty in the real world. It does not assume that we always have complete information. Instead, it listens to new evidence, respect prior experience, and constantly learns, just as humans do. When we define problems clearly, we give direction to our data, we tell the model what matters most. When we ideate, we explore creative ways of merging probability and logic. We are not just crunching numbers, we are re-imaging how knowledge updates over time. Through prototyping, we build models that mimic our thought process, starting small, experimenting and adjusting with every new insight. And when we test, we are validating how close our models' beliefs are to reality. So every round of testing is not failure, it's an evaluation. In essence, Bayesian inference is the scientific version of empathy and iteration. It reminds us that learning is never one time, it continues just as design. Thinkers improve solution through feedback. Bayesian system improve prediction through data. So as we conclude, remember this: design thinking and Bayesian inference share the same heart, curiosity, adaptability and the courage to update our beliefs when new truths emerge. They teach us to never cling to fixed ideas but to evolve scientifically, creatively and humanly, one data set, one insight and more iteration at a time. Thank you.